Hello everybody, so we are back for another video, and what we're going to do in this video is just do a basic overview of how the folder structure is organized in ZooTools Hive. That way, when you're looking for code, you know where to look. We're not going to run through the actual code itself. That's going to take a fair bit of time to go through, and we're going to do that over several videos. So the main thing here is folder structure. So inside PyCharm here, we're just going to go into ZooTools ZooHive folder package, and now I have a completely custom setup of PyCharm with ZooTools, but what you'll find is underneath the ZooHive folder, you'll find a Zoo folder. That's where all our code lives for all our packages. And if you come down to Zoo lives Hive folder, that's our main entry point, and that's the same from a coding point of view. And what we're going to do quickly is have a look at the api.py file. This API file is essentially everything that you have access to, that we intend to have access to when you're writing components, build scripts, and general scripting, your marquee menus, any shelf tools, or anything else you want to build. Now, if it's not in here, then we don't directly support it. We highly recommend always using the API module instead of doing a deep import into the base code of Hive, and that's because Hive will change over time. Files will be changed, folder names might change, even class names may change, and this gives us a little bit of breathing room to make those changes and support backwards compatibility to a certain extent without breaking your code. So here you'll basically find all the functions and classes that you have access to, including all the error types and everything else. So to get access to this in terms of from a coding point of view, I'm just going to open up a scratch file in PyCharm, and what I can do is go from zoo libs hive import API. So from API, you can then basically get access to everything. So that's the main thing of why that module exists and how you access it. So if we go back and back into the folder, you have the constants file. So the constants is basically all of our global variables that we use that store things like names, types, and anything else. These never change in terms of runtime, and they're unlikely to change in the future. So you'll basically go through here, and quite often in Hive, from the API point of view, you'll end up using these constants for practically any access that you need to get to. So for example, attribute names that are part of the metadata to Hive types and anything else you need to do. So that's a pretty important module. Next thing is I'm not going to worry about the anim folder. That's mostly for our tools, and it's something that needs to change quite a bit, so I'm not going to go through that. Base we'll do last because that's pretty extensive. Library is the next thing that's kind of important. So library is something that you don't typically import, except if you want to get access to the subsystems, and if you want to look at like any of our codes for components, build scripts, and so on. So the first one is the build scripts. We have our default build script right here, and this default is on every single rig by default, so hence the name. The main idea is to do things that the API shouldn't do when you're working directly in the API. If you're working through something like the UI or anything like that, then these kind of build scripts are really useful for that. And that's where it's intended to be used. There's not much there to go through in the default. I'm not going to go through the API side, but good kind of examples on what really goes on in Hive. The components is, I would say, one of the most important aspects of Hive, which is part of the build system. So these actually contain your IK, FK components, your AIM components, your God node, and so on. I'm not going to go through, again, I'm not going to go through the code for this just yet. Then you have definitions. Terminology-wise, I'm not going to get into that in this video because it takes a bit of time to get through all the different terms that we have in Hive that may not be too familiar to you. So definitions are basically all the JSON files that we have relating to our components. Exporters, that's where FBX exporter is, and the Maya reference exporter that we use in Hive, when you're actually in skeleton, you want to export that skeleton out as a Maya file with all your geometry and then import it back in and attach it to Hive as a reference. That's where that exists as well. Our template exporter exists there, but currently doesn't get used, but we're migrating to that very soon. Graphs. Graphs is somewhat of a big topic and a complicated topic. to get through because it's about creating serialized versions of a Maya dependency graph into JSON data and then making that reusable. So all of these files, these JSON files, essentially considered like a compound in a graph, and they get reused across our components. So that's a relatively new feature that we have, and everything's kind of migrating to that one step at a time. Naming, that's where our default naming conventions are for all our components, and every naming convention you have in your components, and if you create custom naming conventions for like your presets and so on, it all inherits from these files. So everything you have here is accessible to all of those, and if you don't override a particular name, then you'll just get our default. Subsystems, that's a relatively new one. This is more about code organization, where we now are splitting out individual functionality that components might use, for example, IK, FK, twisting, twist segments, I should say, bendy, and so on, that are heavily reused, but we want to have some way of access building tools from it, and like from IK, FK switching and matching and a range of other things that we need access from an API point of view. So subsystems is a really good way of just organizing your code out into essentially classes that deal with respond to individual events within the build. Tools, so that's mostly marquee menus and zoo commands. So commands is the kind of the UI side of creating undoable actions for Hive. These commands are not meant to be for general purpose scripting, so we don't ever use them for general purpose scripting, and the way that we consider zoo commands is they're never for general purpose scripting. It's mostly for UI development. So if you're writing a UI for, say, a button, and on button click you want to execute a certain action inside Maya, we have a zoo command that you might build up a zoo command for undoable purposes, because we use the API as well, and this will make it so that button is undoable. It's not automatic, you do have to handle undo yourself, but if you're familiar with the Maya's API, then this is essentially a wrapper around Maya MPX command. So in here, we just have organization around, okay, anything to do with components, when you're right-clicking on a component, or you want to say build the component, build the guides, build the rig on this specific component, or just on a set of components, that's where it is. At the rig level, that's when you're doing things like modification of the configuration, visibility of containers, and a range of other things. Just usually just higher level functionality. Marquee menu, that's kind of self-explanatory. You got the set of commands, which is individual actions within a marquee menu, and then you have the menuus, which is in this case, the coded or programmatically built or generated marquee menus. We have ability to do both programmatically generated marquee menus as well as statically generated, and those static generated is done through JSON. Tool UI, this is some kind of like reusable UI widgets that are used in our marquee menu as well as our Hive Artist UI. So we've just kind of put it into here because it makes more sense from a reusable standpoint, because it's something that we'll use in not just the Hive Artist UI, but a range of other UIs that we have in the future. Now getting into the base file. Now what you will see is that there's very little UI code in all of this, and it's because we haven't even touched the Hive Artist UI. I'm not going to go through the Hive Artist UI at the moment because that's a different topic, but the Hive Artist UI is completely decoupled from Hive itself, and the tools, the actual tool UI that we have here, like the build script widget, that is to do with the same, like with the Hive Artist UI, but it's something that's reusable, so we actually use this as well in the preferences UI as well. So this is something that we reuse across multiple UIs. And what this means is that you can build your own UI for Hive if you really wanted to, and there's very little that you have to actually repeat. So because we have commands and so on, that wraps a lot of that functionality. So commands, so libs.commands. This is something that we have in quite a few packages, but the commands section is what the Hive Artist UI and our menus, marquee menus and so on all utilize. And this essentially contains a set of functions that wrap around the undo executor that we have. I'm not going to get into the executor because that's obviously a bit of a long talk and a deep dive into undo stacks and so on. But this module, these has a set of functions that when you do a button click in the Hive UI, simply call one of these and then essentially does a refresh in the UI. That's usually how everything works in Hive, and what I try to do with most of our UIs in ZooTools is that there is some way of interfacing from the core code to UI, and there's a decoupling between the two. Now, all of Hive is accessible from both the CLI, so command line if you're working with MyApply, and as well as if you're working at Mine's UI. So again, this is not meant to be general purpose scripting here. Everything inside the actual Hive API, in this case, is meant to be for general purpose scripting, but everything else, not so much. So the base folder. So this base folder contains everything in terms of like the build system to serialization to exporting, basically the base functionality for exporting, to how the rig works, all the logic, that kind of thing. Now, Hive does have a pretty huge dependency on Maya's API at the moment in terms of the actual core, but everything gets wrapped around it. And the ZooTools framework has dependency on that as well. So everything you see in Hive is actually pure Hive code, and we try to decouple a lot of the logic when we can, so that's reusable in other tools as well. So inside the base folder, the first folder you'll find is the definition folder. Again, I'm not going to go through the code here, but this is a definition relating to passing the JSON data relating to a component and a template, and converting that into a set of classes that we can operate with. And everything here is purely JSON data. So we'll definitely get into why Hive uses a lot of JSON data and raw data structures, but that's where everything lives relating to templates and definitions. And what we have is the component definition, so the comp definition. Keep in mind that when it comes from a coding point of view, you don't access each one of these separately. Like you don't import any of this code directly into the modules. You use the api.py file. If it's not in there, then you don't have access to it. Well, at least we don't expect you to have access to it and expect you to use do a deep import. So definition adders is to do with the attributes within a definition. Again, I won't go through the code until another time, just because these things are like individual videos or topics that do take quite a bit of time to understand, because it can get complicated because it's around about serialization and Maya, as well as serialization into JSON data and back and forth, and syncing that data and stuff like that. Hive nodes. Now, Hive nodes are not custom Maya nodes. Hive is completely native Maya. So in the outer constants, this one's relatively new. You don't really have to pay attention to this one, but just to give you an idea what this one's meant to be for. This contains every attribute that every guide in Hive actually contains. So there's what we call metadata. These attributes are metadata, and it's used within Hive's build system and tools to do things like auto alignment and mirroring and so on. This contains all the settings and configuration for every single attribute that we use for a guide. The H nodes are actually internal Hive node classes. All these wrap around the zappy.dg node or zappy.dag node, and I will get into that later, but that's essentially a wrapper around Maya's API, and it's our own custom one. So everything you do with nodes like controls, joints, there's not many there, so it's just joints, annotations, and so on. Annotation is now a curve, it's not an actual Maya annotation. Layers. So again, terminology, but we'll definitely get into that. Hive layers are something about like organization, but this contains probably most of the API logic that you ever need in Hive, in terms of I want to get access to controls, I want to get access to joints, I want to access geometry, I want to do practically anything. It's essentially built around a query system. So if you want and all the metadata in Hive, so it's actually a Maya dependency graph. That's how it's built, and everything you need to access is essentially attached to these nodes as metadata, and then from there, things like if you want to create a node that's for metadata purposes, this is how you end up going through it. Most of our tools use it, that kind of thing, and pretty much even all our components use it to actually build and construct what you need. It's a very important kind of aspect to the scene organization, serialization, and query system. Serialization, this is relating to graphs. So what you see in the library graphs folder, this is the serialization around that. I won't go through that because it goes through dependency graphs and how to pass them. But the next one is utils, and again, you don't access any of this directly in terms of like importing. But this is just general purpose utilities. There's not many here because we try to keep most of this inside of the Zoo Maya or Zoo Core kind of packages when we can, but these are specific to Hive. So for example, template utils. Some of these functions don't have documentation at the moment because they are internal and I haven't got to it, but this is essentially what we use to merge templates together. Definitely get into that because that's a kind of a reasonably large topic to get through in terms of how to load templates, how template loading works, how definitions work, and how scene structures work. But you can have a look at through that code. Twist utils is something that's pretty commonly used in our VChain, ARM, and leg components. So it's a set of functions for that. Our mirror code is all in here too. So the mirror utils, that is actually a lot simpler than what people think, and there's not too much to it. It's a combination of mirroring a transform in world space and doing a custom lookout function to handle auto align. So that's reasonably well documented, but some of the code might be a little bit messy for you. Hey, there's a print statement I need to remove. So this will go through all this code will actually go and run you through the mirroring, how it all works, how mirror behavior, mirror orientation, mirror scale, all that kind of stuff works, and the logic behind that. The next thing is the build scripting. So this is the base class for all build scripts. We have throughout all Zoo and Hive is a plugin based system. So most of the stuff when we have something that's meant to be extendable, we have a plugin type that we essentially subclass from, and then you can, as a user, can subclass from it. So for example, a base build script, you can subclass from that, then register that to Hive, and it will now know about your build script. This is reasonably well documented, but examples are kind of lacking in terms of like comprehensive examples. The component.py, that's a reasonably large file. This contains the entire build system for a component and like the code logic on how Hive actually does a build, and your components will subclass from this and override certain functions and so on. That's a reasonably large code file. If you really want to be jumping into it, go for it. It takes a bit of time. So the next one is configuration. So the configuration file is essentially what the actual configuration class should say is what the actual rig uses, and each component has access to that same configuration and always uses the same configuration. So you don't have a separate configuration per component. You do have a separate naming convention preset for each component or configuration for each component, but you only have one rig configuration. This contains all your settings, like whether black box is on, whether you're using proxy attributes, what build scripts you have active for that particular rig, and so on. It is also a way to get access to the registries. So registries are essentially so you'll see here, you don't access the class like this, but there's actually individual functions for this. But these are essentially just classing variables that hold the instance of the registry, so we don't have to constantly discover each registry every time you initialize a rig. It doesn't make sense, that's too slow. So this contains all the components you actually have access to across all Hive, the templates, the graph instances, and the build scripts, exporters, naming presets, so on. Those classes can actually be accessed if you scroll down to basically near the bottom of that class. You then actually have class methods that access that particular registry. Now, again, you don't typically access that configuration by itself. You can if you want to get access to registries or like default state, but this class is instantiated for every rig instance that you create. So, but the registries are basically singletons. Error module contains every error class that we have and custom error. Exporter plugin, again, it's basically a base class to plugins for exporters. This is for FBX exporting. If you want to build your own USD exporter, go for it. If you want to like export a rig to GLF2 or something, then you can do that too. Naming, this is the custom code for naming conventions. Typically, this is done for internal purposes. Most of the time, don't think you will need access to any of this, if I remember off the top of my head. Yeah, so this is the stuff that we use internally for our rig. I'm just remembering what the code was doing. So this is all used for internal stuff. Don't typically need access to it. Naming presets. This is the actual naming preset manager that we have. The actual core code behind naming is actually inside Zootools package because we actually support that across all of Zoo. Not that we use it that much, we only use it in Hive at the moment. This contains the logic for how presets are loaded, saved, accessed per component, and so on. Registry, it contains all our component, like our actual component registry, template registry, and so on. So if you want to know how components are discovered, like the logic behind it, then you can just grab, like say, go into the component registry here, and then you'll find a section here that says plugin manager. I won't go for the plugin manager at the moment. I will in another video because that's a super handy utility class for registering essentially a set of classes based on a set of interfaces, and it means that you can have this is how all of ZooTools is like managed, is plugin instances, or plugin manager instances. So then finally, there's the rig.py. This is the entry point to essentially creating rigs, to accessing rigs in the scene, and that includes accessing the actual individual components and saving loading template code is all inside here at the moment. Not all the code, it's just the load function and so on is in here. So you got the rig class, which is the actual Hive rig instance. You can see a little bit of a basic code block there, which is an example for, okay, you're going to create a rig. I want to start a session. In that case, when you're starting a session, it's doing a lookup across the scene to find that particular rig. If it doesn't exist, it'll create it for you. And then you can access all the individual component instances that rig actually has. And this can be utilized at any point in time. So you can use it while you're building a rig, you can use it while you're inside of animation and you're like trying to build tools. And you can also do it for like pipeline related tools, like if you want to do exporting, batching, and so on. That's pretty much it for all the base section here. There's not much to go through except for the prefs. So the prefs is the last part, and that is if the base preferences is like ZooTools prefs is just a set of JSON files that we copy and merge down and upgrade into your user preferences. And this is super handy. Any Zoo package can ship their own set of preferences. But if you go into here, you can see that this is essentially all the individual user preferences that a person can use. And you can find a really important one here, which is called naming preset hierarchy. What you see in the Hive preset UI actually comes from this. So that's our default preset hierarchy, and then you have your own locally as well. This includes things like having a set of plugins get loaded when a Maya rig instance gets initialized, and a bunch of other things. These are all just defaults, so that gets essentially merged on top of the rig configuration. So inside the assets folder for the prefs is the build scripts. So these are not what we use for default or our general purpose rigs. These is usually purely built for the rigs that we actually ship for users, and same with the templates. So these templates is what we ship, including our rigs in the ARM template and biped template and so on. Again, this all gets copied down onto user preferences, so they don't actually get used directly from this location. Naming presets, that's where our UE5 naming preset lives. So you can actually look at this and go, this is how it works, this is how it's designed and so on. Unit testing is the other one. So there's not much to unit test, unfortunately. Something I really need to work on. That's a bit awkward, but there is quite a bit. It's just not enough to cover 100% of Zoo at the moment, especially all the different operations. Hive is the rigging system is very, very complicated. So most of our unit tests are not about units of work, but more about system tests or integration tests, where we're basically testing large sets of code where we're running a single function like a build, and it runs it over across that. And that's how we're managing our unit tests right now, because there's so much code that and it also gets changed quite a bit. And it's all mostly internal, so backwards compatibility is very rare to break. But you find that you have unit tests for testing Hive nodes, for example, and for the guides and so on, just to make sure that things are getting created correctly and queried and so on. The next couple of things is probably going to be the docs folder. Documentation is probably going to be another video on how documentation gets generated in our actual technical docs, because that's actually really, really useful, because you have access to the generation of technical docs in ZooTools. So you can create your own documentation and then tell Zoo, hey, can you generate me the HTML documentation statically? And now I actually can, if you're a studio, especially for a studio, this is really handy. You can tell it to generate the whole documentation, and then you can put it inside the studio, like on a web server or something like that, or just copy it onto an external drive, and now they have access to it offline as offline docs, which is super handy. So docs, for example, has the source folder, but you'll see it has nothing else. It just has the source. It just has all this. And it's because Zoo manages all the individual packages and builds them all at once and merges all the documentation into one kind of big ginormous HTML doc. And then there's the very final file, which is the zoo package.json. So the zoo package.json is the configuration file that says, hey, this folder is related to ZooTools. Please install it or load it up or recognize it as a zoo package. So the most important part here is the environment, which contains all the environment variables for Hive, and this includes where all marquee menus are and where the components can be found, definitions, and so on. This also allows you, if you just look at this file, you'll be able to find out how to extend ZooTools to contain your own plugins for exporters and definitions, components, build scripts, anything else you want to do. It also includes like creating compounds, graph compounds with the graphs concept, as well as marquee menus. With that, that's going to be the end of this video, and I'll see you in the next one where we start diving into the Hive API.